Hello, this is Diego Muya, and in this video I'm going to talk about the OWASP top 10 most critical web application security risks. OWASP is a project, it's called the Open Web Application Security Project, and provides a series of resources that would enable web developers to produce more secure web applications. This list was compiled in 2017, and we are going to go through all the security risks one by one, and you will see that you know some of them, you might not know some of them. So let's just go one by one. Here is showing the difference from the previous compilation in 2013, and most of the security risks remain the same. They might have shifted a bit from place to place, and they have identified some new security risks that became more prominent, like the XML external entities. We will talk about it later. So, okay, let's go one by one. The first security risk is, let me just go down to it, injection. So let's just make this a bit bigger. So injection is something that we have seen in other videos, has been covered before. Is the possibility that the user can inject some code so that it can be executed in the server. So examples that we have seen in videos, in past videos, is, for example, SQL injection. This box here is saying how easy it is to exploit, and it's level 3, means that it's very easy to actually produce the exploit. Basically, as soon as there is, for example, a web form where the user can provide some information, then the user might write some code there which could be used, run by the web server. This box here says how easy it is to detect. It's actually fairly easy to detect. We have seen in some videos how easy it is to basically to prevent this particular in case of injection. Basically, you need to make sure that you protect all the fields and you parse the information. This box here is saying how serious is the damage if that exploit happens. And again, level 3, you could lead to a very damaging results, because if any code can be run in the server, you could in theory delete databases or even access to some important files on the server, because this code is actually run using all the permissions available by the server. So it could do really big damage and basically break the server and remove important information. Here is giving more information. I'll leave it for you to read this part here. It says what kind of applications are most vulnerable to injection, which is when the data supplied is not validated, and some more information here that you can actually follow on. And there's an example that shows how you can some particular code that shows how the exploiter can make the exploit. And in this first example is based on some possible SQL query in which the server allows the user to fill some part of the information, for example, through some web form. And then that form is not passed, and maybe the user produce some executable code. In this case, this is in Java code, so this could be a Java application, and that code is doing something which is not what the web server was meaning to do. This part here will say how you can prevent information, which is using a safe API. In the case of Bottle, you would use the template system in which you use the question marks to indicate which parts of the SQL is going to be provided by the user, and then providing the information on a separate component of the command, and then Bottle is going to parse the information and escape all the code so that it cannot be executable. So this is the first one. The second top 10 is a broken authentication, and that's when the possible cracker, the evil person, might manage to log into your system by using exploiting some very poorly managed authentication systems, or by allowing to accept very simple passwords which can be easily guessed. So again, it's very easy to exploit, and it's very important. It can have a very serious effect. And it could happen when, for example, the system allows what is called credential stuffing, in which you could very quickly try many different possible username and passwords without allowing for any possible delays, or it would allow any batch list of login. So the actual attacker could try many, and eventually might find some. And also, if the system allows some simple password like password1, admin, and so on, then that could be tried. So the way to prevent this is to basically to avoid this the credential stuffing, doing some weak password checks. I don't allow some passwords which are the most common password, like the ones listed in this top 10,000 WASP passwords, and to encourage more complex passwords. Number 3 would be sensitive data exposure, and that's when the web server doesn't encrypt sensitive data or allows somehow that data to be accessed by somebody else. The most common approach is that when there is some data like password information, credit card information, health information is not encoded in a secure way. And so that could be exploited fairly easily again, and it could lead to very important problems. So the way to check if the application is vulnerable would be to, if the data is transmitted as in clear text, like using protocols which are not secure protocols like HTTP, then you shouldn't allow to transmit password or credit card information using this protocol. You should use different kinds of protocols. Here, I would like to highlight one scenario, a more attack scenario, scenario number 1, in which the server actually encrypts the information, say credit card numbers, in a database, but using the automatic database encryption. And that means that even the data is encrypted, when you use the standard database operations to retrieve the data, it's going to be decrypted and send the decrypted information, or return the decrypted information. So actually, that is not a very safe kind of encryption, because this is for example, some injection approach. You could actually enforce the database to decrypt the data for you and give you the password information. The third or the fourth or the top 10 security risk is what is called XML external entities, and that's when it is using XML information, XML data. We see in other videos the use of data by the web server like JSON or XML. So there are two possible kinds of formats. In XML is a very complex data formatting system and very flexible, so it allows to include some entities. And we can see in the example shown in the attack scenario, you will define an entity XXE is like a template, and then whenever that XXE appears in the XML file, like using this form of notation, then it's going to be expanded with whatever we say. In this case, the attacker is saying, well, just fetch the file, the password file, and that's the expansion of our entity. So by doing this, the attacker can actually see all the password information. So a way to prevent this would be to, well, if you can strict the way you use the XML file, do it. Or for example, consider using JSON. JSON is being used instead of XML more and more often. And it's possible that in the near future there will be very little XML information being passed on through the web. But still, if you have to use XML, because JSON cannot encode every kind of information, and if you want to use XML, just make sure that you explore how the entities are being used and try to avoid this kind of exploit. Number 5, broken access control. That is when the user has access to information which is not authorized to access, but happens to be placed in a place where the user cannot have access. You can see this clearly in the scenarios shown here. Scenario number 2, maybe the server has some URL that is returned to the user example.com/app/getupinfo, and then the user could actually edit the last bit and maybe type instead admin_getupinfo. So try to access to a different resource, and it is a file code like that which is meant to be for the administrator, not for the user, then you will have access to it. Another example, which actually I do quite often myself, just remove getupinfo and just have access to try to find the directory listing. By default, most web servers, if the path ends with a slash, and if that's referring to a folder, it would list the entire folder. So by doing that, you can actually see if there are any files which might have some names which might indicate there are some possible secret, some password or some extra information. So a very easy way to prevent this kind of problems would be, first of all, to prevent the default behavior of listing the directory when you provide the slash at the end of the path. And another easy way is just to avoid putting any files which are not meant to be in that place. So be very careful about what you keep when you deliver your product, what you keep in your folders. Number 6, security misconfiguration. That's when the server doesn't configure the security properly. For example, the security level is lowered at development stage, and then when it's sent to production stage, it's not raised properly by keeping some default accounts or some demo programs which can be exploited by the user. Number 7, cross-site scripting. This is a topic which has been covered in other videos in this unit, and that's when the user has the ability to make other users to run some arbitrary code. In that way, the attacker can have access to some information in the browser of the user, or can pretend it is that the user and doing something, like make it possible to make the server send some user information to the attacker. Number 8, insecure deserialization happens when the system uses a serialization process to encode information. Serialization basically means the ability for a program to encode some complex data, like an entire Python structure or entire JSON data, into a very compact string. For example, you might want to use a super cookie which contains a lot of information, and an approach to do that would be to use a serialization approach to encode that complex data structure into the cookie. But by doing that, you actually enable your passing has too much information through the HTTP, and then that can be found by the attacker, and then they can actually have access to that maybe super cookie and get some information which shouldn't have access. Way to prevent that would be, of course, to try to, first of all, to have secure deserialization process, and try not to encode too much information when you pass information between the browser and the server. Number 9, using components with known vulnerabilities. It's many applications, especially after a while, attackers find flaws, and then some patches are provided, but the web developer might use an old version which has been applied a patch. And then the longer you keep a system without applying patches, the more likely it is that a security flaw has been detected and can be exploited by the user. So an easy way to solve this problem would be always to keep the most up-to-date patches. And finally, number 10, insufficient logging and monitoring. It happens, it's very common that an attacker manages to attack a system and is not discovered for a while. So, for example, in 2016, there was an average of 191 days from the point between the attack happened and when it was detected. That means that the attacker has plenty of time to get into the system and try to find more efficient ways to do more and more harm. So a way to prevent this to have some frequent logging and to make it possible to run some automatic checks on the logs to detect for any suspicious activity, so that any possible attack is detected as quickly as possible. Well, that's all this top 10. Of course, there are many more possible risks. These are only the 10 most frequent, and they were scored according to some ranking set by OWASP, which is all listed towards the end of the document. But just somewhere around here. But there are many, many more. So you should really pay attention to security and look at any possible new security risks and try to make the system, well, better. Thank you.